Hello, everybody. I'm not Dutch. I'm wearing just a T-shirt from like 4 years ago because they didn't have T-shirts this year. I'm from Hamburg, actually. This is also where the picture is taken from a big container ship. I also organized the AppSec conference in Hamburg 2013. Who has been in Hamburg 2013? No. Oh, only 2, okay. You were? Not very much. Do I need the mic? Or is it okay?
Yes, please. Otherwise, it will not be recorded.
Okay, good. Yeah, this container ship is there for a couple of purposes. First, it's a container ship. Then the picture is taken in Hamburg, about 5 kilometers from my place where I live. And the third reason, which is a little bit not so good reason, it lost some containers in the Dutch shore, at the Dutch shore. I think it was January or February. So, yeah. This is me, myself. Some of you might know me, some not. I chaired as I said, the AppSec conference in 2013 in Hamburg. I did a lot of other stuff for following conferences, also running a local, well, we don't say chapter, we say Stammtisch in Germany, a meeting in Hamburg since 2010. I'm an open source guy. That's the best thing also about what I like about OWASP. Open source journey started for me way earlier, long before Linux was there. So I was at the university compiling window manager, bootstrapping compilers, web browsers, and stuff, only to get on the workstation, on the Unix workstation, things running. Was kind of a Gentoo feeling, but a little bit more difficult. Yeah, besides OWASP Docker Top 10, I also have an own project, which is TLS Checker, which is Test SSL SH. Who ever heard of it? Okay, a few. Not bad. In my paid time, I do consulting. In the early time, I did programming, but nowadays, 10 days, I'm not a developer at all. And I did a lot of Linux and or system and network security way back. That was the time before application security became interested for me. Now the interesting thing for me is that Docker brings the two worlds together. So let's get started. What I want to show you today is the OWASP Docker Top 10. As the banner says, the project is not complete yet. This is somehow the layout of the talk. I'm talking with the motivation, the idea behind it, and then we finally get to the status where we are at. And the major part is presenting you some details from the content. I'm afraid I can't cover, due to the complexity, all the content. So let's get started, starting with the very basics. Understand what you're doing. So this might sound a little bit weird, but the container technology is helping developers to get things tested and deployed in a solid manner so that he can fulfill his work and satisfy the customer, right? From a classical standpoint, you had a couple of different systems and built complex networks. At least you should build some complex networks. And a typical developer is no network and system security expert, so isn't an average ops guy. Formerly we said system administrator. And often there are no architects either, neither for system part nor for networking part. What I've seen in consulting jobs, auditing Kubernetes and Docker environments was not so good. And also what research has been published last year, maybe you remember that Tesla had an open interface where there were AWS credentials there, which people used for mining. There were etcd from CoreOS was open. there were other research from Lacework where dashboards, APIs, and all that stuff was found open in the internet. That led me to the conclusion that also bigger companies sometimes have problems getting a grip on the technology. So as said, container security is a pure system and networking security topic. The project is suggesting controls to minimize attack surfaces, but also to get for the people involved to put them onto the right path, building in the first place the system. But not only for them, of course, if you have an external contractor, we'll do that for you. You also can put parts of it in the contract. You can look at it, which makes sense for you and what not. Also for auditing such an environment, it's supposed to be helpful. Okay. What the project is doing is trying to analyze the threats. Right, because some things do appear different if you look a little bit closer. This is a very easy scheme of threat modeling. There were a couple of vectors which evolved. They're not only vectors, but they're also concrete technical threats. I'm focusing on a few, on the most important ones here. Which is the host and the orchestration. The host carries the containers. The biggest threats is coming either through the network from the host, which is sometimes not safe, or directly through a Docker process, right? The orchestration is your management backplane, and normally what the most important thing is to be safe that you don't have open interfaces there or well-configured interfaces. Okay. Good. So during the rest of my talk, I will mainly focus on the red boxes and go a little bit more in detail. This is how the Docker Top 10 looks like. Similar to the OWASP Top 10, there's a little bit introduction. The threads I already talked about. And then there's an overview, what comes, and then the 10 points are listed. In the end, there is also some information what's next. Maybe I won't have the time to go through every slot. And this time I gave a similar talk in London last year already, where I covered basically everything. Now it's time to pick the most important ones and go a little bit more into detail. So, other than the OWASP, the regular OWASP Top 10, the application Top 10, is we don't have a one-page layout. We have as much space as we want for each point, which is very good. So this is approximately how it looks like. You have 4 points. The structure is always the same. First, there are the threat scenarios. Then it tells you something, how do I prevent those threats in my system? And then if you're not aware whether we have them, you can also have a look at the configuration, and there's then a recommendation what you can do to find out. Okay, and finally, of course, there are references. So let's start with the second point, patch management policy. That might sound boring for the most of you, but actually it's still a crucial point of most environments I saw, because people just want to leave the things running instead of patching. Because sometimes, so there's the old saying that 50% of the security posture is patching in time, right? That's the opportunity window which the hacker has. Surprise, surprise, that also applies here. You remember also the A9 in the OWASP Top 10, which says using components with null vulnerabilities. Patching in time, as I said, is crucial. The how and when is mostly a policy matter. And after the policy comes the technical implementation, which just is fulfilling the policy. So the complicated thing with in the container world is that you have different patch components or patch domains. You have the host, you have the container orchestration, you have container images, and maybe if you install Docker or Docker shim by hand, you also have to patch them in time. So I'm going now through every of those components. Coming to the host, a severe threat to a containerized environment is, for example, that you have a Linux kernel weakness unpatched for a longer period of time, and the application breakout into the container, into the microservice, and the guy downloads some stuff and finds a system call under also Docker as a cage, right? Which is caging or containing stuff. But native operations like reading files, opening network sockets, and so on and so on, those are system calls. System calls go into the Linux kernel, the underlying kernel. So if that system call has a problem, the host is gone, and all containers on it is gone, or is basically compromised. Not gone, compromised. So it's very important also to think about patching in time a Linux kernel and how to deal with it, especially kernel patches. And of course, also patching doesn't help alone. You also often need to reboot, right? Besides those syscalls in kernel space, there are a variety of bugs, which can hit a Linux server. Netflix found recently bugs in Linux and also in FreeBSD, which is called for Linux. It's the so-called sec panic. Sec is a selective acknowledgement. That just means that if a transfer of TCP packets over the network might sound easy for you, but what the kernel does is actually kind of difficult, because TCP packets might not appear in order as they were being sent. So, and also packets might be dropped. So there's a buffer of 17 packets basically, and what the vulnerability used basically, sometimes those buffers are merged, and while merging the buffer there was an overlap which led to a vulnerability, to an overflow. This can be just this could be just initiated by sending just a couple of forged TCP packets. So as a result, the kernel and with all containers would stand still. So as I said, patching in time is important. But it's not only the kernel itself. Often you have services running. I get later a little bit to it. One service you might want to run on the kernel is NTPD, NTBD. It's provided by most systems, by the OpenBSD community. But also in the past, there were severe, the score. This is a slide from cvedetails.com, which is a very convenient site for looking up threats. And CVEs for a specific program or application. Well, there were a couple of remote overflow and remote exit code executions in NTP in the past. So if you have NTP, for example, exposed to your container network where the host is running, and you don't patch it, it's bad, right? Because the attacker, which then would sit in the container, broke out of the application, can attack the NTPD. So there's a hint for the host, which is good. If you don't run a full-blown distribution, every Linux distribution nowadays has a method auto-applying patches. For Debian or Ubuntu system, it's auto-update or unattended upgrades, which they can configure packages which you don't want to have installed. For example, if you don't have kernel packages installed, or if you don't want to have all the Docker stuff installed because you're afraid it tears down your container while you're not there. You don't have to do that. You can also only apply security patches and not only functional patches. It's very flexible. You should look into it. If you want to get notification about outstanding patches, up list changes is a good thing, where you can just configure that emails are being sent for outstanding patches. Just the monitoring part of it. So getting to your orchestration software, no software is bulletproof. It's done by humans, last but not least, and also not your container orchestration. Looking at Kubernetes, there's a list of known path vulnerabilities at cvadetails.com, which I retrieved last week. I think it's sorted by score, yes, by CVS score. As you can see, there were in fact some vulnerabilities, and 4 of them, I think it was 7.5 is critical. 4 of them were critical. So that happens from time to time. So it's also a vital component of your what you're operating. You need to patch it. So. And Kubernetes seems to be a kind of problem sometime. I don't know really what to think about it, but it seems to be a piece of software which in fact could do a little bit better. Also, oops, what is that? Let me go back a second. Yeah, I think I pressed the wrong button. So here we are. Okay. Good. Sorry. Okay. There has been a code review or code audit from the Cloud Native Computing Foundation recently. Again? Oh, there we are. It's not me. So I'm trying to present you a little bit on 3 slides the results, which sound a little bit strange to me. At first, they had 3 months, or let's say 12 man weeks, looking at it. And these are the I put the links in there. The slides will be available later on, and also the document. The report is at GitHub. It says manage the audit for 4 months time span, and they complained about a high complexity of code, actually 2 times. And the code has significant room for improvements. Code base is large and complex, and it has a lot of duplicated code, right? Which sounds not really good in my experience. And so they focused on 8 core components. And they found in those 8 core components, within 12 weeks, 37 vulnerabilities, which itself doesn't sound so bad. But on the first glance, at least. But from a code review taking place in 12 weeks, I would have expected more bugs to be found. So either the people are really not good in reading the code, or the code was not good enough so that they can get a clue what the code is doing. So I'm tending a little bit towards the latter, because they were complaining about the code. The severity of findings really doesn't reflect what they said before, because 5 high and 17 medium is not particularly bad. It's not good. I would say maybe average somehow. But if you look at the details, I recommend reading the PDF. There are some things which are scratching my head. I know I have a hard time, easy time standing here and just telling bad things about what the code looks like. I've never looked at the code, and I have never reviewed the code. To log secrets and credentials is not what I would have expected from people working, providing such a frameworks. It's also kind of surprising to me to execute shell commands in Go. If you read the PDF, it's kind of funny because it reminds me on early times where I did some Perl programming, so that they just executed shell AWK commands and passed the AWK commands, got some arguments there, and they pass the arguments then again in Go, which sounds strange to me. Okay. Missing error handling and potential dangerous operations, as on the right side listed, sounds also not very good for me. So I just would recommend that you go yourself into the documents and trying to understand it and get yourself a picture. Okay, but that was a short insertion. Coming to image patches now, you also have a mini distribution there. The best probably is to tear down containers. Often, last but not least, you're using Docker framework, and I suspect you're deploying your containers very often. You tear down, renew your application, don't know how to deployments do day by day. So that's also the equation when you just update the image, the base image from the mini distribution. If you deploy some containers not really often, like a database, you should at least have a schedule when you update them, because also they can contain security patches. And also, well, I'm not talking about monitoring images now, but you can also, of course, monitor them. Or should. Depending on which distribution or software using, container software is normally updated through host operating system. This means Docker, Docker and Docker Container Shim. If you install it manually, which I never would recommend, you'd also need to take into account that ExchangeNet might require a reboot. So one of the important points from the architecture perspective is network segmentation. So who knows what? Who of you knows what do I mean by that? Okay, good. Network segmentation is basically a architectural thing, how you lay out your networks so that packets which you want go from network A to network B. But not anywhere else. You have routing between networks, you have firewalling between networks. This is completely different in the container world. I'm telling you how it was in the very old time of firewalling. As the first firewalls evolved, one had a demilitarized zone. There was a firewall facing to the internet. Behind that was an application. Or a web server sitting, and everything else. There was a database server. There was most often the local area networks, so the LAN was there. So everybody behind the firewall was equal, right? All packets were routed. There was no firewall or whatsoever behind it. So this is not what you want. You want protection between firewalls. You don't want that desktop computers, for example, can access potentially the web server, which is exposed in the internet, right? Because also desktop computers might have a problem. So it seems like in the container world, this concept of just having a firewall and behind it everything is flat has some kind of a renaissance. Because some people just tend to whatever, make a host or bridged network, which is a bridged network is a /24 network most of the time, and put all containers in there so that people can happily talk to each other. So it's also difficult because, for example, you do want services, microservices, which need to talk to each other. you want them to talk to each other, while others don't need to talk to each other. That should be forbidden. So, hello? Okay, that helps. So this is year 2019, and you don't want to go back in time where everything is in one network. So you need to carefully decide upfront what you're going to do. You don't want a front-end container. I would not touch it. Let's leave it, I guess. If it's getting worse, we can work on it. But for now, I'm happy. Still. Yeah, you don't want to talk the front end to Tomcat management ports or to maybe even other tenants or for other microservices which they shouldn't talk to, right? So this is a picture which is from XKCD, which just reflects a little bit the situation, right? Okay. 1, 2, 3. Okay, it's back. So this is the problem we are coping with. So how to do that properly? First step is to segment the network and then decide who really needs to talk to each other. The latter you do with routing or firewalling. For the firewalling part, I get later to. A rough segmentation is basically happening with the network driver. First task is choosing, well, the network driver. There's a handful of drivers for Docker alone. For Kubernetes, there are zillions of drivers to choose from, and for both there are also plugin drivers available. So let's assume, just for the sake of this talk, we're doing bridged or going for bridged networks. That means everybody has a closed IP address which I can reach or not reach from the outside. So I'm using bridge networks then to separate the networks from each other because, for example, from the database into another network, I create another bridge network and I can control then the communication between those networks. I can control the communication between a front-end container and a database container, for example, if I put them in one network. That's not possible, really. So, yeah, for tenants, situation is a little bit more difficult. I don't have time for slides for doing basically a system segmentation. What I recommend there is also doing VMs for if you have multiple tenants to put behind it, and every tenant would then have an own VM. So network design is one thing. For now, we kind of covered that in a simple manner, but there are also systems we need to talk about. So we are DO4, secure defaults and hardening. They're basically also the three domains: orchestration tool, host, and container image. They potentially can offer something which isn't needed. Which can be an interface, an open interface, a not needed interface, an interface with a vulnerability, or just binaries which are there and could be used by an attacker. So the golden rule of thumb is what needs to be run needs to be there, and what doesn't need to run can be just removed or shut down. This chapter has also a part regarding firewalling. So in the previous version and on GitHub, that part belongs, I still have to update the GitHub page, the GitHub pages, the documents. In the previous version and the GitHub, it belonged to the previous chapter, but it fits better in here. So coming to the orchestration tool part, that's basically your management backplanes. In the data center, for example, if you have console access to servers or to anything like routers or firewalls, they have serial consoles. You put those devices because they are very powerful in a dedicated management LAN. So this is also how you should treat the Kubernetes, for example, etcd, kubelet API, and so on and so forth. So you should control, or you should check whether you need a dashboard. I think for Kubernetes it's not installed by default, and you should also check whether they are open. The interface is open means no authentication is needed. So just a glimpse. I think I talked about that. No, I didn't talk about it yet. It's kind of confusing because I'm frequently looking at the documentation. There was a bug actually for the kubelet API on port 10.250 and 10.255, and on GitHub it seems like the points were resolved in versions nowadays, and the documentation is still the same. So which means that everybody through API calls through Kubernetes can manage the container. I haven't seen a default installation since some time, so I can tell. So there was a report I mentioned last year, security foot gun in etcd. There was a guy discovered that CoreOS in previous version had etcd, which is a key value store, open, and looked around in the internet and found a couple of them. That means basically it's a key value store. It stores keys with its values, and surprise, surprise, he also found tokens and keys, and actually a lot if you look at the numbers here. So so those are things which you just want to have to be aware of. And what I'm trying to say to you, or tell to you, is that you should watch for any interfaces which are out there. I'm assuming though you don't expose them in the internet at all, but you should also have a look whether they require authentication or not. I did, by the way, OWASP is not an offensive conference, but I took a quick shot yesterday, and it actually seems that at least lots of etcds are still around in the internet, and also there were some data in there which maybe shouldn't be there. Okay. So next important is the host. First, I'm describing what choices you have for the operating system. If you go for Debian or Ubuntu, it's just a Debian Ubuntu distribution. It's not a specialized container operating system. So if you want to have everything small and really good for your containerization, you should consider a container OS. Because if you go for Debian or Ubuntu, you should at least do some handcrafting on it in order to make it application ready. I'm going to next slide for that. The container operating system, some of them I listed here. Who is using, anybody of you using VMware Photon, by the way? Is anybody knowing it or looked into it yet? Because for me, it's kind of appeared a couple of months in front of my eyes, but I never heard about it before, and they seem to be around for some time already. Okay, good. As said, if you take a standard distribution, don't install a shitload of binaries and libraries which you don't need. You don't need a compiler or desktop distribution. Choose a server distribution. This is your bare-bones system. Best is if you're able to inspect each package, whether it's needed or not. It's important that you lock down every service. Some Linux distributions, depending on what you're installing, has the MDNS services there. RPC services are gone, mostly on Debian, and Ubuntu services. Kups is for printing, and you don't need file sharing also on the server. But some are started by default. So then you should log into the machine and as root and check what service is running. You can do lsrf-i-p, which gives you a list of services running here. You only see TCP services, and there are a couple of services which are exposed somehow on all network interfaces. With bridge networks, you have multiple network interfaces, right? And on this host, you expose them on every network interface. There's the kubelet APIs I talked about recently. SSH, you probably don't need, facing to the container. 6556 is started from XINID, which is a monitoring thing I'm going to talk later about. This is happening especially on older Debian and Ubuntu distributions. It's just for NFS file sharing, but you shouldn't start them, right? etcd, everything which is localhost is fine. The kube master, the fact that here's no star, but kube master tells that the etcd here is only listening on one interface. But of course, it depends also on the routing, whether from a bridge network, for example, they can reach etcd. So next step is to apply some custom hardening to the base operating system. There's a tool, if you handpick packages and shut down all the servers, you can use Linux, for example, to do a final configuration. You can also use, should also use that on the container OS. Sys has also a Linux benchmark, but to be honest, I haven't looked at it because the Linux benchmarks are for every distribution and for every released distribution, and that kind of turned me off. But that shouldn't stop you. That shouldn't stop you from looking into it. What is important? If you have more than one host, so if you want to reinstall the host, that you're using a configuration management tool like Ansible or Salt, so that your changes are documented, and also you can again reinstall the host in a reproducible manner. So you saw previously on port 6556. This is what I experienced on an audit at a customer side. So there was this port showing up. I knew that is checkmk. Who knows checkmk? Anybody? Okay. Not very much. checkmk is a monitoring system which needs an agent, and it has basically also a master somewhere, and the agent just collects the status of the components, which are here, for example, DF, the occupancy of the usage of the disk, PS process list with all Docker and processes on the container, and all kinds of Linux variables and all that stuff. Okay. Basically, there's more. I'm going to back later, but this I discovered from the container side. I used the container to go there. Not here in this picture, but also later on, and from the outside. So checkmk has also a problem. It has a weak default installation, right? You put it on the server, and you just can telnet to it, like I did, and you get all the information served on a silver platter. So. I talked about system calls already. There are several means of, I think I should not spend much time on it. There are over 300 system calls under Linux. As I said, file open, opening network socket, rename files, and so those go directly to the kernel. So if you don't want a couple of calls are not needed, you can reduce them with seccom profiles, which is JSON, in JSON format, and you can specify which you don't want, right? Firefox and Chrome on Linux does that already, and also Android has seccom profiles for lots of applications. So this is a little bit difficult, because it requires good knowledge of Linux system call internals. A little bit easier, but still somewhat hard on digesting is the capabilities, but they are great. Capabilities come basically before syswords and control what a process can do. This applies also to Docker process, because from the kernel perspective, the processes, the microservices running in there are just processes, right? There are currently 40 Linux capabilities, so you can look for that with pscap. Here is an excerpt for a for a proxy, which is Quid, which lists 28 Linux capabilities. For Docker, normally you see 14 capabilities, which is significant reducing the capabilities, but I'm sure that can be reduced for every container, if not completely taken away, because you don't need to create device files in a container. You don't need to change root in a container. You don't need to construct raw packages like for ping. So ownership, maybe set ownership, set UID is also something which you probably don't know, which you probably don't need. So it might be worse if you want to put the bar a little bit. It cannot hurt if you want to put the bar a little bit higher, that you trying to restrict the capabilities. That can be achieved with capprop. So now to the content of container. To the content of the container, here you can and should pay special attention. As most of people know, API Linux is not only smaller, but also contains less binaries. For example, there's no ping there, but it also includes so-called hacker tools like netcat and wget, which are very useful for an attacker, right? So this is kind of unfortunate because BusyBox is very flexible. They have a menu configuration where you just can tell which binaries are built in there. And also if you move the links in a container, the functionality is still there. So, but Alpine shows to check those boxes. So that's the reason why you have to live with them. Anybody uses distroless? Oh, okay. Nobody. Distroless is a neat feature, requires a little bit of work because basically you have a multi-stage process that you build one container and you copy basically everything, including your application, over to a new container so that you don't have commands like ls, ps, grep, and no packet management system. Right? So this really, so you have really only the core which is needed for your application. Yeah. It doesn't make sense for example, for script languages. You have a Python or Rails in a container. The hacker can use Python or Rails to continue with his dirty deeds, right? He doesn't need to use shell commands. Firewalling. So, as said, we now segmented the network a little bit between network A and network B. And now we have the task, if there are no if there are routing rules between the networks, we can also get a grip to route, for example, to the MongoDB database, which is in bridge network B, right? Because I can just put some rules in there. I can also protect checkmk if I don't want to switch on the application, which is this is how it approximately looks like. I need to add a few iptables command, which is the command for adding a kernel-based firewall rules. First, I whitelist the port 6556 for the agent with the source IP from the monitoring master. And then I log all remaining packets, and then you can, and then you log everything, and the rest you just drop. So, but the problem is, I think it's on their slide. Yeah, let me just check. Yeah, this is how you can control network boundaries and also protect each service in there. So if you followed me now from the network security perspective, you might understand why I think network design is not that really easy, especially if you have more than, let's say, a handful of Docker containers. So you can also verify yourself if I miss anything and scan yourself. You can scan. First thing, you should scan yourself from the outside, whether you have maybe you're one of the candidates which have etcd exposed in the internet or the Kubelet API exposed in the internet, which you shouldn't do. My tool of choice is Nmap for those kind of things. So, but then you can also, you should, of course, from internal, you should then check the host, the orchestration from different points of your network. You can also build an Nmap container and scan from a container's perspective. This is what I'm doing sometimes, so that you get a clue how much is exposed from the container point of view, whether this particular container can access the Kubelet API, which is not supposed to, or can go to another tenant, or the host, which has some service running, which I don't like. Okay. Maybe I'm skipping this. This we left off a little bit with checkmcar. This basically would have been a chapter I'm closing now. What checkmcar also does, I don't know whether it does per default, but at least has the capability to run Docker inspect and Docker network inspect and those kind of things. So this chapter where it belonged to, where I basically wanted to talk about, is about managing secrets. And so by telnetting basically on the host from the container network, I could retrieve passwords. I got them served on a silver platter. So this is why you are not supposed to use unauthenticated checkmcar, not expose it to the container network, and not using credentials passing via environment variables. So basically, I'm concluding now. So I talked a little bit about what's next. That's still in the works. This is the end. So when you think you can contribute to it, please come to me. I'll be around until the very end of the conference. Otherwise, thank you for your attendance and your for everything. Bedankt.
We have some time for questions. If you have a question, raise your hand.
Are your top 10 ordered by risk, just like the other OWASP top 10s?
No.
So what is your ordering then?
That's a good question, actually, because the OWASP top 10 basically has a few statistical data. I don't have that much statistical data. It's a mixture between guts and best practice. The points I felt are more important, a little bit more with the early numbers, and the ones which are maybe a little bit more optional or things which could be very useful are more in the back. But if you think that should be reordered differently and have good arguments, we can discuss.
You mentioned in your slide that we have to kind of use small images like you mentioned in your slide that we have to use kind of small images like Alpine and something like that. But the problem is even in this distro, we find a lot of vulnerabilities. It's already online. And the problem is they don't have a really good packaging system. So sometimes the developers if they need to have some kind of libraries or packages, they have to go and compile it. So it's the same thing.
The C library, yes, the C library is not full blown on Alpine. I don't know even whether I can reinstall the glibc, for example, which some applications use. It's a suggestion, right? I would, where it works to use a Alpine Linux, I would go for Alpine Linux. Where it doesn't work, you shouldn't use it, of course, right? Yeah.
And don't you believe that we have to start using jail on FreeBSD instead of Docker? Don't you believe that we have to start using jail on FreeBSD instead of using Docker?
Well, the jail technology is way older. I can't tell how good it is because I lost a little bit. I think it was 2004.
2000. FreeBSD 4.0.
Okay, this was the earliest thing. I can't tell really. But FreeBSD is also an operating system which has problems, and jail might also be a technology which also has problems. I don't know whether there's orchestration available because, Okay.
Okay, thanks.
Okay, sure.
We've run out of time, and the keynote is starting very soon. So thank you very much.
Thank you.